Now, doing that within the context of like an upper bound budget is interesting and is totally an open area in field robotics. If you're interested in that, Bayesian optimization literature and literature about overfitting models that you're training for machine learning has some interesting thoughts about it.
Do the p-set?
Yeah, so if you're doing Warren and Takaya's awesome p-set, you can get a preview now.
Let me read this up really quick. So, the key thing to understand about the p-set is hopefully you kind of glean from this lecture is adaptive sampling, the core overall algorithm is just a few steps. The complexity really comes in how you choose these things and how they interact with each other in a way to get that emergent behavior you would expect for your robot to execute. So in the p-set, we'll look at different world models, several different Gaussian processes with different kernels, and they kind of naive Lewis and Amber type classifying map. We'll look at a pure explorer, pure exploiter, and a kind of weighted difference of those things. You'll look at different horizons to represent your actions by. Then you'll also be able to choose your own budget, and the goal is to kind of implement that, which is kind of the simple part, but then the hard part is like you'll be asked to think with several plotting tools we would build for you to kind of think about how these things inform the behavior and how it differs from your expectations and how it might hint at some of the limitations of the classifier-based belief models we're using in the p-set. So we're kind of trying to help guide through some of the different variables that are kind of latent in here and how they can kind of confound with each other. So if we jump over, yeah, so it's already outside. Okay. So yeah, first we'll just touch on information gain a little bit. Keep going now. We'll focus on entropy mainly for our information gain metric, but then we'll also talk about other types of the generalization of entropy and when you might want to use it, and keep scrolling down. So then we'll kind of just scroll through a belief model representation, the different types of kernels, what it means to have a non-optimized kernel versus an optimized kernel, what you're optimizing for, and we just scroll through this. I don't want you guys to like look at the code too much because that's your part. Just scroll all the way through. Yeah. So just go to the very bottom. So then you'll implement your own sampler here.
Wait, we're writing all this.
No, most of it's just testing. Most of it's just run the code and like talk about the differences between the two.
Wow, a lot of words.
Let me give you one specific example. So like in this example, you're not implementing anything here. You're just playing with the number of neighbors, the types of kernels, then answering qualitative questions about the behavior you see from using different types of naive classifiers versus different types of kind of global classifiers from adding random points or not to that set. So the actual code in the first two sections is very limited. It's more about tweaking things and seeing how that affects your belief map from what you would expect. And then in the last part, this was about here's an example of the two actual questions. So the first part, the code's very limited, but there's lots of examples to kind of help walk you through some of the differences which point out potential limitations that you'll see later on. So then the last part is implementing an actual sampler. We list some of the assumptions here. You don't have to do any control or anything like that. Just move between different points, and you'll move as long as you're below a certain budget. So these are the actual methods you'll be implementing. The exploit only explore, then kind of a weighting difference of the two, and then moving through here. We've giving you some ways to query the actual truth world and how to interact with it. But after each of the tests, or after each of the methods you implement in your assignment class, we're going to have a test for you to kind of show that piece of the problem's working. Then as you go through, the movement cost is relatively straightforward. So then the last section, which towards the bottom here. So then the last section is asking you to, now that you built your Explorer, it's really focused on how are those different things between your belief model, reward function, and set of actions you're considering interact to give you different types of behavior. So we'll give you this test explorer function. Then we've kind of built 12 different scenarios where you just have to run the cell, and as long as your explorer is built, it'll run through it. So if I go back up really quick. So that this is just showing a beta value of 0.75. So in this context, it wants to explore, so it's kind of going around a certain region to kind of really find the boundary of that region, but it's also valuing exploring the gradient feature. But as you see, kind of as you gather certain points in one area using a Gaussian process, that has some kind of unintended consequences on the map based on it being a classifier-based kernel. So we'll ask you to kind of try and explain that intuitively, and when you want to use that for maps. So you're going to use different horizons, then you'll use different types of kernels to represent your so you don't have to code any of this stuff. This is there, and as long as your sampler works, it's more about just walking you through different cases to kind of qualitatively think about the behavior you'll see. Then there's two final cases that are left open where you pick your own budget, look horizon, beta value, and belief model. Then just using the examples above, you would pick those and try to either look for some way to break it, so that it does things that you wouldn't expect, either because the belief model is kind of breaking down, or to just try to describe how it meets your expectations of that. So not too much coding, more about thinking about the different parts of adaptive sampling, because I think that really is the core, is knowing when to use which aspects to fit in the overall adaptive sampling algorithm. And then in the P15, there's also this great
tutorial.
tutorial that really walks through a lot in more detail.
What's the reference for that?
It's okay.